Hi guys, this is Madhaji Patil here for Sports to Science. Today we are going to be looking at blood flow restriction training for athletes. So, what is this blood flow restriction training? This was something that was found in Japan or developed in Japan, or before it was known as Katsu training, named after the person who found it. So they used to basically strap something around their hand to restrict the blood flow and do the training. So the idea behind it is basically using a cuff or a band to restrict the blood flow, venous blood flow, something that is very important, venous blood flow, while maintaining arterial blood flow. We know that veins are basically the superficial one, and the arteries are basically deep hidden inside. So here, what we are trying to do is we are trying to restrict the blood that is going back to the heart, while we are allowing more blood to come into the muscles. So this it is said that it promotes hypertrophy and even strength at a very lesser loads, like 20 to 50% of 1 hour. Generally, while training, it is said that it's better to use very high intensity to see the best results. Here, what we are saying is if when you are using BFR training, only 20 to 50% of the intensity of the 1 RM is required. So it mimics high intensity training effects via metabolic stress. So, what is this metabolic stress? How does this BFR training work? Who is it used for? How is it useful? And we'll see a few athletes who have used it in the upcoming sessions. Now, let's see how this metabolic stress and hypertrophy can be linked. So, in BFR, again, as we told, reducing the venous outflow increases the metabolic stress here. So, how does it actually work? So, because of this metabolic stress that is being put, there is more increase in lactic acid production, and there is a difference that is seen in the acidity levels. So, because of this, there is fast twitch muscle fibers, type 2 muscle fibers, which are being recruited because of the stress and the increasing production of the lactic acid and stuff. The brain will start to uh, tell the muscle that okay, now we have to use fast twitch type of muscles. So because of this BFR, even at lower loads, the fast twitch fibers are activated. Second one is cell swelling, because which causes anabolic signaling. So as we told before, this there is lactic acid production and lactic acid development, and there is H plus ions that are being produced, which kind of causes to draw in the blood, draw in more water into the muscle cells. So because of that, there is a swelling that is seen. This swelling will actually send a lot of anabolic signals, which will help in hypertrophy. Again, because of the same reason of the lactic acid and H plus ions, there is elevated hormone levels like GH, IGF-1, and at times testosterone too. So what does this do? All of this will end up helping in protecting the muscle, at the same time increasing the anabolic levels. So there is an anabolic effect that is seen because of these following hormones too. Next, it triggers reactive oxygen species because of the local hypoxia and myokine responses. So, reactive oxygen species or ROS is basically seen when there is stress that is kept because of the oxygen. Because of the less availability of the oxygen, you will see a stress. So, this ROS is generally termed as harmful, but in this case, for very less amount of time, this ROS can be seen helpful, which help by increasing the anabolic signals. This myokine response is also seen where there is building up of muscles that are seen. It downregulates catabolism markers. So this BFR training, because of the stress that is kept on it, to save the muscle, it is said that myostatin, which is a protein, and other proteins which increases the catabolism levels, they are downregulated. The number of these catabolic markers are lesser, which in the end will help in hypertrophy. Till now, we saw how this BFR will help in increasing the muscle hypertrophy or maybe the strength. We understood the science behind it. Now let's try to understand what is limb occlusion pressure. So the minimum pressure that is needed to occlude the arterial blood flow into the limb. So it is mainly measured using Doppler ultrasound or pulse oximeter. Okay. So how does this work? Is we know there is a cuff that we use to check the BP, like blood pressure. Same way, you put that on, you take a pulse oximeter which understands the pulse, or a Doppler ultrasound which helps you give a audio feedback of the heartbeats, or you use a stethoscope. You keep it in the try to find the radial pulse. You keep it there. After that, what happens is when you increase the pressure, you in the cuff via the pump. What happens is there is a point at which the blood you will stop hearing the sound of the blood flow. From that, you will start slowly loosening it, and we will stop at the correct point where we find the blood flow is starting back, which means that okay, there is enough pressure for the blood to go into the limb. As we told before, the veins are superficial. So what happens? The venous blood flow is reduced. It is close to none at this time. So the pressure at which where there is arterial blood flow happening, but there is but the venous blood flow is reducing is known as limb occlusion pressure here. So for a person to use or do the activity, it is said that it is required to check the pressure on both the limbs, lower body and upper body, legs and hands, also on the left and right, both the sides. Maybe because of the placement or maybe because of the activity of the previous day, there will be a change in the pressure in left and the right. So it's very important to check both the sides. Now there are different factors that can affect the pressure. So the first one that we see is width of the cuff. The wider the cuff is, lesser pressure is required to stop the venous blood flow. Circumference of the body part. The bigger the body part, the more pressure that you need to use it. So obviously, compared to the hand, the leg will need more pressure. So position of the patient. So something that we have to clearly think is that if the patient is lying down or standing or sitting, all of this will have different pressure that is required for the blood to flow. So it is better that we try to look at the pressure for the athlete. Let's take an example. If the athlete is going to do shoulder press from here, so sitting at this position, now we are going to lift the weights. It's better that we check the pressure at this position where they are going to do the activity. Next, very important, hydration status. If the athlete is dehydrated, there are chances where the pressure reduces, and if the athlete is overhydrated, there are chances where the pressure increases. So it's very important to understand the hydration status also. Now, recommendation. Now we saw how to even take or how to take the occlusion pressure, how to understand it. Now we'll see the recommendation. How should you use that value? At what range should you train? So, as a general recommendation, 40 to 70% of the atrial occlusion pressure should be used to see the results. So 40 to 70% of it. So let's take a small example. As I told you, how to take the radial pulse, check the radial pulse and understand the pressure for the limb. We got 150 mmHg is a part where you start seeing the atrial blood flow coming back, or AOP, atrial occlusion pressure, AOP. From that, you take the 40 to 70% and train in between that. This is a general recommendation that is given. But according to G and Wang, in 2020, there was a research that was done in 2025, which said that person should do 40 to 70% of their 1RM, a weight which is 40 to 70% of their 1RM, and using 60% of AOP, 60% or more of their AOP, and which can promote immediate upper limb strength. So that's good. So we can understand that, like, if a person can do 100 kg bench press, you take 40 to 70 kg and use a blood pressure which is 60% or more to their AOP, which can easily give better strength. So it is also said that BFR can be used for weight training sessions for 8 days to 8 weeks to see results. So in a lot of cases, there are studies which are done for 8 days and studies which have been done for 8 weeks, where they do it 2 to 3 times a week. If it is 8 weeks, while weight training session, there are still a lot of results that are seen while doing like this also. Now we'll see why BFR. Why should we use BFR? First one is improve strength, as we saw before. Because of the responses, this can easily improve the strength. Other than that, increase hypertrophy. As we told, there are a lot of anabolic signals that are seen while doing this. Improve in performance. As we told, if there is strength and hypertrophy that is seen in most of the sports where hypertrophy is required and most of the sport where strength is required, there you can directly correlate those two to help you in performance also. So other one is endurance. Here, something that we have to say is it all can also help you improve the lactate threshold, as we told before. Because of the reduction in venous blood flow, what happens? There is more lactate accumulation that is seen. So, if you trigger it properly, there can be good endurance changes also that are seen in athletes. Now, this can be used for starting athletes. So, let's take example a person or an athlete who is starting to train weight train. After they have understood the form, this technique can be used because they cannot easily push to higher weights, but at the same time they'll see a result in the athlete. Again, as we told, lesser weights. The same results of as much as pushing of 1 RM is seen when they're doing using BFR at lower weights. Injured athletes, something that is very important. This is easily is can be easily used in rehabilitation process also, where the higher load can cause injuries, can easily cause injuries again. So what happens is for those athletes, it's good that we use take 40% to 70% of their 1 RM, and you can do the same. You can get the same effect of a high intensity 1 RM press with this lesser intensity because of BFR. Now, let's see a few athletes who have used this before. Dwight Howard, and a very famous NBA player, have used it. I've been seen using it. From the same coach, Lindsey Stroker, USA weightlifting athlete, both of them have been going under the same coach and have seen using BFR. Next one is Michael Andrew. He is an Olympic medalist. He has also told that he has been using this technique while swimming itself, using BFR while swimming itself. Not we generally see weight training. Here he has done it during swimming itself, and he has seen a better improvement in the performance at the same time in hypertrophy. Next one is Kyle Markle. She has done it majorly during her rehab sessions where she could not lift higher weights, but she wanted the same effect. So she used this BFR at lower levels, lower weights, and got the same results, and it kind of helped her go through the process. So here today we saw BFR technique. How does it work? Where it can be used? Who all have been seen using it? And I hope this information was very helpful. Thank you.